Obliterated models, norm-preserving guardrail removal. The open-source AI community continues to push against the boundaries of model safety restrictions, with a new technique gaining traction for removing refusal mechanisms from large language models while preserving their core capabilities. A Shanghai-based developer has released a norm-preserving obliterated version of Google's Gemma 3 27B instruct model, using what's called the biprojected obliteration technique to surgically strip away safety guardrails. Obliteration refers to methods that identify and neutralize the internal directions in a model's representation space responsible for refusal behavior, essentially finding the no vector and zeroing it out. The norm-preserving variant aims to do this without degrading the model's reasoning or general performance, a common side effect of cruder approaches. The release has sparked discussion about standardizing naming conventions for these modified models. Different developers use different tags: MPOA, derestricted, obliterated norm preserve, making it difficult to search for and compare variants on platforms like Hugging Face. As one commenter noted, the original norm-preserved biprojected obliterated descriptor is unwieldy, but keeping obliterated prominent at least signals the technique's lineage. The underlying distinction between model restriction and dataset filtering also surfaced. Restricting a model modifies its behavior to refuse certain requests, while filtering pre-training data simply leaves the model ignorant of filtered topics. One causes active refusal, the other produces genuine knowledge gaps. The developer, a practicing lawyer who works with AI companies on legal matters, included the standard disclaimer that the model is for research purposes only, a fig leaf that does little to constrain actual use, but at least acknowledges the ethical minefield. AMD Strix Halo Budget AI Inference arrives. For those unwilling or unable to pay NVIDIA's premium, AMD's Strix Halo platform is emerging as a viable middle ground for local LLM inference, albeit with caveats. A new discussion around the AMD Ryzen AI Max Plus Pro 395 highlights a system with 128 GB of LPDDR5 memory available for around $2,100, a price point that puts substantial memory bandwidth within reach for hobbyists and small teams. The platform, based on the RK3588 class Strix Halo chipset, offers roughly half the GPU performance of NVIDIA's DGX Spark, but at a fraction of the cost. Memory bandwidth approaches Apple's M-series machines, though the software ecosystem remains the primary concern. The ROCm situation has improved substantially since launch, with users reporting stable llama.cpp inference on ROCm 7.0 nightly builds. VLLM support, however, remains a major PITA, requiring source builds with extra steps, inconsistent model compatibility, and suboptimal performance when it does work. For large mixture of experts models, where memory capacity matters more than raw compute, the platform shines. One user described the progress as real but still too unstable to be considered reliable, a fair summary of AMD's perpetual status in the ML ecosystem. Intel's BattleMage alternative was dismissed as abandonware, leaving AMD as the only credible non-NVIDIA option for those who don't want to invest in Apple's ecosystem. The community resource at strixhalo.wiki tracks compatibility and performance, reflecting the grassroots documentation effort that often substitutes for official vendor support in this space. Developer tools, proxies, monitors, and pipeline. A flurry of open-source tooling releases aims to smooth the rough edges of working with AI coding agents and local models. Linker, a new Node.js proxy, mimics the Claude Code API while routing requests to Databricks-hosted model endpoints, enabling teams to get the familiar Claude workflow, repo-aware answers, file edits, tool calls, while staying within their own infrastructure. The project emphasizes compliance friendliness and vendor lock-in avoidance, with features like Git integrated diff review, commit message generation, and prompt caching to reduce token costs. For enterprises already invested in Databricks for data and model hosting, this bridges the gap between internal capabilities and the polished experience of commercial coding assistants. On the monitoring front, a macOS developer built Agent Sessions, a Rust application that displays all running Claude code sessions in a unified interface, solving the mundane but real problem of losing track across multiple terminal tabs. The tool auto-detects agent sessions and shows idle counts in the system tray, a small quality-of-life improvement that reflects how coding agent workflows are becoming complex enough to need their own management layer. Meanwhile, AI Runner v5.5 added the ability to masquerade as Ollama, allowing integration with tools like VS Code Copilot Chat that expect Ollama's API. The caveat that you can't run the real Ollama simultaneously is an obvious limitation, but for those who want AI Runner's specific model management and want it to just work with existing tooling, the feature offers a pragmatic bridge. A Tiny Llama fine-tuning RagLab toolkit also appeared, promising a unified pipeline supporting full fine-tuning, LoRa, and QLoRa on Google Colab's free T4 GPUs. Questions about ROCm and CPU support remain unanswered, suggesting the project is early stage. For users with hybrid NVIDIA setups, such as a 3090 paired with a 5070 Ti, the community continues to puzzle over optimal configurations, with no clear consensus emerging. Graph databases and memory for AI agents. Graph databases are finding renewed relevance in the AI agent ecosystem, with two projects targeting different ends of the complexity spectrum. NornicDB, released under MIT license, provides a Neo4j-compatible API with GPU-accelerated vector embeddings, now supporting both CUDA and Apple Metal. The developer reports 43% performance improvement from Metal acceleration on an M3 Max, with initial benchmarks suggesting 2 to 10x speed improvements over Neo4j on standard benchmarks like FastRP and Northwind. For applications that need both graph relationships and vector similarity search, a common pattern in retrieval-augmented generation systems, this could simplify the infrastructure stack considerably. Separately, a project called Memory Graph offers an MCP, Model Context Protocol server designed specifically for coding agents, providing intelligent relationship tracking through a graph database backend. The MCP standard, developed by Anthropic, is becoming the lingua franca for tool and context integration with AI models, and purpose-built memory servers like this one address a genuine gap. Most coding agents lack persistent, structured memory across sessions. The ability to track relationships between code entities, conversations, and decisions could substantially improve agent coherence on longer projects. Video generation. Longer, better, faster. Video generation continues its rapid evolution, with new tools addressing the persistent challenges of temporal coherence and efficient inference. The Comfy UI Painter Long Video project introduces nodes specifically designed to fix slow-motion artifacts in accelerated LoRa workflows like LightX2V, while also enabling generation of longer videos with consistent motion, global scene coherence, and slow-motion correction. A particularly interesting addition is Painter FLF2V, which uses inverse structural repulsion to enhance motion between first and last frames, essentially pushing the model to generate more dynamic intermediate content rather than the static or subtly drifting sequences that plague many video models. Apple's StarFlow release represents a more fundamental architectural contribution, introducing a transformer autoregressive flow model that achieves state-of-the-art results in both text-to-image and text-to-video generation. The 3B parameter image model operates at 256x256 resolution, while the 7B video model handles up to 480p at 16 fps, with support for variable length output, from 5-second clips up to 30 seconds at 481 frames. The key innovation is combining autoregressive modeling with normalizing flows, enabling faster sampling through blockwise Jacobi iteration while maintaining quality. The repository includes full training code, configuration files, and pre-trained checkpoints, with the model licensed under Apple's Open Model License. For researchers, the deep, shallow 6-block architecture and causal attention mechanism offer interesting design choices to study. For practitioners, the drop-in VLLM compatibility and comprehensive scripts lower the barrier to experimentation. Reasoning models and expert pruning advances. The race for better reasoning models continues with Intellect 3, a 106B parameter mixture of experts model post-trained from GLM 4.5 Airbase using supervised fine-tuning followed by large-scale reinforcement learning. With 12B parameters active per forward pass, the model achieves impressive benchmark results: 98.1% on Math 500, 90.8% on AM24, and 88.0% on the notoriously difficult AM25. The training infrastructure, environments, and model weights are all released under MIT and Apache 2.0 licenses, making this one of the more thoroughly open reasoning model releases. The FP8 quantized version fits on a single H200, while the BF16 version requires two, reasonable requirements for organizations wanting to deploy competitive reasoning capabilities without API dependencies. For those seeking even more efficiency, Cerebras released Minimax M2 REAP 162B A2B, a 30% compressed variant of the 230B parameter Minimax M2 model that maintains near-identical performance. The REAP, Router-Weighted Expert Activation Pruning, method identifies and removes redundant experts based on both router gate values and activation norms, preserving the router's input-dependent control over remaining experts. Unlike expert merging approaches that can cause functional subspace collapse, REAP maintains the model's generative capabilities, particularly important for code generation and creative tasks. The 30% pruning rate reduces total parameters from 230B to 162B, while keeping per-token activation at 10B, with benchmark results showing single-digit percentage drops on most tasks. The model works with vanilla VLLM, requiring no source modifications, which dramatically lowers the deployment barrier compared to many compressed variants. Gaze redirection in computer vision research. A University of Southampton paper introduces DIT-Gaze, a framework for high-fidelity gaze redirection that represents the current state-of-the-art in manipulating where a person appears to be looking in an image. The work builds on Gaze Gaussian, which pioneered using 3D Gaussian splatting for this task, but replaces the U-Net renderer with a diffusion transformer, DIT architecture. The technical contribution centers on three innovations: ADA-LN, adaptive layer normalization, conditioning for effective signal integration, an intermediate gaze sampler that trains on synthetically generated intermediate angles to create smooth gaze transitions, and an orthogonality constraint loss that enforces disentanglement between gaze, head pose, and expression representations. The evolution from 2D image warping methods to 3D-aware approaches reflects the broader computer vision trend toward geometric understanding. Early methods treated gaze redirection as 2D image-to-image translation, producing artifacts and poor spatial consistency because they ignored the fundamental 3D nature of head and eye movements. NeRF-based approaches improved accuracy, but suffered from computational demands and slow inference. The 3D-GS-based Gaze Gaussian achieved real-time performance while maintaining quality, but struggled with subtle, continuous gaze shifts. DIT-Gaze reduces gaze error by 4.1% compared to the previous state-of-the-art, reaching 6.353 degrees, a meaningful improvement for applications like video conferencing gaze correction or training data augmentation for gaze estimation models. The two-stream architecture that separates face and eye regions into independently controlled Gaussian sets enables fine-grained control that single-stream approaches cannot match. Audio reasoning and dynamic scene understanding. The MDAR, multi-scene dynamic audio reasoning, benchmark addresses a significant gap in how AI models are evaluated on audio understanding. Existing benchmarks focus on static or single-scene settings, failing to capture the complexity of real-world audio environments. Developed by researchers from Fudan University, Shanghai Jiao Tong University, and IEIT Systems, MDR comprises 3,000 question-answer pairs across 5 reasoning categories: scene understanding, social relationships, event reasoning, temporal reasoning, and anomaly detection. The benchmark uses Chinese movies as source material, leveraging their multi-threaded narratives and high production values to construct complex dynamic scenes characterized by openness, high entropy, long temporal dependencies, and strong causality. A key innovation is the introduction of multiple choice questions with multiple audio clips, a first for audio reasoning benchmarks. This format challenges models to integrate information across audio sources while handling mishearing, omission, or bias, more closely approximating real-world decision-making scenarios. The evaluation of 26 state-of-the-art audio language models reveals sobering limitations. The best open-source model, Qwen 2.5 Omni, achieves only 76.67% accuracy on single-choice questions, with GPT-4o audio reaching 68.47%. No model exceeds 80% on any question type. Qwen 2.5 Omni struggles most with temporal reasoning, 71.43%, while GPT-4o audio has particular difficulty with scene reasoning, 61.27%. The 25-second average audio clip duration, significantly longer than MMAU's 10 seconds or MMAR's 20 seconds, contributes to the difficulty, as does the requirement for genuine reasoning rather than pattern matching on short, isolated audio events. Custom policy enforcement for AI safety. NVIDIA's Nemotron content safety reasoning model tackles a persistent limitation in AI safety: the mismatch between generic content moderation and the nuanced requirements of real-world applications. An e-commerce chatbot that needs to avoid culturally sensitive topics, a telecom support bot that must prevent unauthorized billing advice, or a healthcare application navigating HIPAA compliance. None of these fit into a one-size-fits-all safety policy. The current alternative, brittle prompt engineering or manual rule sets that fail under complexity, leaves developers perpetually patching edge cases. The 4B parameter model, fine-tuned from Gemma 3.4b, introduces reasoning-based safety that interprets policies dynamically rather than relying on fixed classification logic. The training pipeline is particularly interesting. It begins with distillation of reasoning traces from powerful models, DeepSeek R1, Qwen 332b, GPT-OS 120b, followed by difficulty-aware refinement that identifies samples neither too easy nor too noisy for training. A key efficiency innovation involves extracting one-sentence summaries of reasoning chains, delivering up to 40% speed improvement over traditional reasoning models without decreasing effectiveness. The dual-mode inference option, reasoning on for maximum flexibility, reasoning off for minimal latency, allows developers to trade off between interpretability and performance. The model accepts 3 inputs: a policy definition, the user prompt, and optionally an assistant response, predicting compliance with a brief explanation. Running on any GPU with 8GB plus VRAM and compatible with major inference frameworks including VLLM and TensorRT LLM, the model lowers the barrier for organizations wanting custom safety enforcement without massive infrastructure investment. Claude versus Codex. The agent comparison continues. A developer using a tool called Rover to compare coding agents across identical tasks reports consistent text. Claude wins over OpenAI's Codex, though with nuanced observations about their different approaches. The key differences emerge in how each agent interprets instructions and interacts with existing codebases. Claude tends to respect context, expanding existing implementations rather than rewriting them, while Codex gravitates toward optimal solutions even when that means restructuring what's already there. For consistency-focused development, the former approach is generally preferable. Maintainability often trumps theoretical optimality. Claude also adheres more strictly to explicit instructions, avoiding unsolicited additions like tests when not requested. Codex, by contrast, sometimes adds related but unrequested changes, which can be helpful or annoying depending on workflow preferences. Perhaps most practically concerning, the developer notes that Codex occasionally enters loops on complex tasks, with some taking 45 minutes compared to Claude's consistent 10-minute completion times. The comparison awaits testing with the new Codex Max model, which may address some of these issues. The broader pattern, Claude's instruction-following discipline versus Codex's more autonomous behavior, reflects fundamental design philosophy differences that likely won't disappear with incremental model improvements. FreeBSD 15.0 and system infrastructure updates. FreeBSD 5th release marks a significant milestone for the operating system, introducing the PK base system that allows the base system to be managed via the PK8 package manager, a fundamental shift from the traditional distribution set approach. The release also features a rootless build process for release artifacts, a native Inaudify implementation that simplifies Linux software porting, OpenZFS 2.40 RC4, and OpenSSL 3.5.4 LTS with quantum-resistant algorithm support, MLDSA, SLHDSA. OpenSSH 10.p2 includes quantum-resistant key agreement by default, reflecting the growing urgency of post-quantum cryptography preparation. The PEB-based approach is offered as a technology preview in 15.0, but is expected to become standard in future releases, with traditional distribution sets planned for removal in FreeBSD 16. For AI/ML practitioners who prefer BSD over Linux, this release improves the viability of FreeBSD as a development platform, particularly given the native Anodify implementation that many development tools expect. The release supports AMD 64, AArch 64, ARM v7, PowerPC 6464LE, and RISC v64 architectures, with pre-built VM images available for major cloud providers including AWS, Google Cloud, Microsoft Azure, and Oracle Cloud Infrastructure. Separately, a Hackaday article highlights progress on UEFI support for ARM single-board computers, specifically the ROC5 ITX Plus with its ROC chip RK3588 chip. The EDK2 RK3588 project enables UEFI firmware on this board, bringing the kind of standardized boot and configuration interface that x86 users take for granted. The journey involves caveats, specific HDMI ports for output, SPI flash requirements, kernel version dependencies, but the result is genuine UEFI capability on ARM hardware. The RK3588's increasing upstream kernel support makes it a promising choice for Linux-focused SBC applications where the traditional flash microSD card and pray approach feels increasingly anachronistic. Escaping Electron Bloat, the Spotify solution. A developer blog post offers a detailed guide to replacing Spotify's Electron-based desktop client with Spotify D, a background service that accepts Spotify Connect commands without the memory overhead of running yet another Chromium instance. The motivation is familiar to anyone whose machine struggles under the collective weight of Slack, Discord, VS Code, and similar Electron applications. Each one bundles a full browser engine, consuming hundreds of megabytes of memory for what should be lightweight functionality. The setup involves installing Spotify D via Homebrew, configuring it with Spotify credentials stored in the macOS keychain, and optionally pairing it with Spotify 2i for a terminal-based control interface. The process requires a Spotify Premium account and involves some configuration file editing, but the reward is an extra half gig of memory, freed from Spotify's grasp. The post includes updated notes reflecting the author's evolving relationship with the solution. Initial enthusiasm for Spotify 2i gave way to controlling playback from a phone via Spotify Connect, and eventually abandoning Spotify entirely for Apple Music. For those committed to Spotify but frustrated by its resource consumption, Spotify remains a viable alternative, assuming you're comfortable controlling playback from your phone or a separate interface. Phone farms under fire, infrastructure resilience. A cryptic but intriguing project page documents the challenge of running hundreds of phones in conditions where infrastructure may be subject to drone strikes, presumably a reference to operating in conflict zones or areas with active military activity. The project describes itself as Phone Farm as a Service, suggesting an infrastructure as a service offering for running large numbers of mobile devices. The context raises questions about the applications involved, ranging from legitimate use cases like mobile app testing and automation to more ambiguous scenarios like social media manipulation or fraudulent review generation. The technical challenges of maintaining device farms under adverse conditions are genuinely interesting from an infrastructure resilience perspective. Power management, network connectivity, device health monitoring, and physical redundancy all become critical when the operating environment may experience sudden disruptions. However, the sparse documentation available provides more questions than answers about the specific implementation or intended use cases.